Awesome. So we are going to present to you how car engines work today. So we're going to go over in this presentation, we're going to answer some questions. So how do cars actually move? You're going to find out what parts are in engines. And you're also going to find out how all the parts work together. We're going to help answer these questions by going over the combustion cycle of an engine, the core components of an engine, and the various subsystems of an engine and how they all work together to actually make that car move.
Yeah, so the first thing to look at is the combustion cycle. This can be considered the heartbeat of an engine. This is where the power comes from. What's happening in the combustion cycle is gasoline is being burned and it's exploding, and this explosion is being harnessed to provide power to the car. In most modern car engines, there's a four-stroke cycle that happens. The first is intake, then compression, then combustion, and then exhaust. So if you look at this diagram, it models the different cycles of the combustion cycle. The first is intake, where air and fuel is taken into the cylinder. Then it's compressed and squeezed down. And then in the combustion cycle, a spark ignites the gas and it explodes. This is the stage where the power comes from. And then after that, all the waste gas and air is then pushed out of the cylinder in the exhaust cycle. So here you can see an animated graphic of what's happening in this process. As you can see, each of the colored graphics correspond to one of the cycles. Intake is again where air and fuel comes in. The second stage is combustion or compression, where it's squeezed down. Third is where the spark happens and it explodes, and that's where your power comes from, and it pushes the piston down. Then the fourth stroke is just pushing all the waste gas and air out of the engine. And this is kind of, again, the heartbeat, the main part of a car engine.
Great. So there are many different kinds of engine configurations. Almost all cars have more than one cylinder. Car engines also vary in the number of cylinders, their arrangement, and their size. And we have a little picture later on this slide showing you different kinds of engines and their configurations. And all different combinations have different purposes and capabilities. So, for example, we have a V-twin, that's most common in motorcycles, a flat four, a V6, and a V8. And those are all different configurations of cylinders, numbers of cylinders, and that can influence the power of your engine. So think about maybe why would you want to use multiple cylinders and why you would want to use larger cylinders in a configuration.
So next we're going to look at some of the core components that really make up the heart of the engine. As you can see, the different colors are coordinated with the combustion cycle stages that we talked about. All of this is housed in what's called the engine block. In this graphic, you can't see it because it's kind of made transparent so you can see into the engine. Engine block is basically the metal block that holds all of the components. Then you can't see these either, but in between, at the very top of each of the cylinders, there's something called a spark plug. That's what sparks and actually ignites the fuel. Up top here, you can see the different, there's different valves along the tops of the cylinders that are on springs. Those are opened and closed at specific times. These are opened at specific times by what's called cams. They're kind of the egg-shaped or teardrop-shaped lobes that rotate and then push down the valve and opens it. Otherwise, they remain closed. These are all connected on a camshaft that is rotated by something called a timing belt or a timing chain, depending on your car. These keep them moving at the proper timing, since timing is very important in an engine. Down below, you have the crankshaft. So this is actually what all of the pistons are connected to. And when the explosion happens and combustion happens, that's rotating the crankshaft. And that's what actually sends the power back to your car. The flywheel is right here on the end. That is connected to your transmission, which has all your gears and lets you move at different speeds. But that's kind of the connection point between your engine making the power and then the transmission that actually puts it to the wheels so that you can move in the car.
Great. So now we'll kind of cover what the fuel system looks like. The fuel pump will move gas from the fuel tank to the engine. Modern cars actually have direct injection, where gas is injected directly into the cylinder. You can kind of see that described in this graphic. We start at the fuel pump, where you put the gas in through your car into the fuel tank. It runs through the fuel lines, through the fuel pressure regulator and the fuel injectors that inject that gas directly into your engine. And then the fuel injectors, you can see this is kind of a close-up animated graphic of kind of that image. They'll spray gas directly into the cylinder at the precisely timed moment.
So another thing to mention with the fuel system is the octane rating. A lot of you have probably seen this at the gas pump. There's different numbers on the different types of fuel. And some people don't really know what they mean. The octane rating is essentially a rating of the fuel's resistance to auto ignition. Auto ignition is what happens when the gas explodes or combusts without a spark. This happens by purely compression. Certain fuels, if they are compressed to a certain point, they're going to ignite on their own without having a spark or flame or anything to start that. Auto ignition is really bad for your engine. If you ever heard of knocking in an engine, that's what this is going on. Is the fuel is exploding before it's supposed to, and it's messing up the timing with the engine. This is something that's really bad, which is why high octanes are needed. For premium fuel or really high octane ratings, you really only need those in high performance scenarios because those engines use above average compressions. So you need something to resist that so that auto ignition doesn't happen. One question to think about, knowing what octane rating is and what it's measuring, is premium or high octane gas better for your car? Or another question, is it necessary for an average car?
Great, and then we'll go into the air intake system. So air enters the front of the car, and the filter removes the particles and debris, as you can see in our GIF to the side here. The valves control air into the cylinders. And the ratio of fuel to oxygen required is actually 1 to 14. 1 part of gas requires 14 parts oxygen in an average car. You can see that kind of illustrated here in this GIF off to the side.
The cooling system is another very important part of an engine. You guys may have experienced this if you've ever opened the hood of your car shortly after driving it. There's a lot of heat that comes from that, which is why the cooling system is so important. Engines, they get very hot, and the antifreeze, which is also called engine coolant, is what's cooling the engine. It's housed in the radiator, which you can usually see on the very front of your engine when you open the hood. A water pump is used to circulate this coolant throughout the engine. It basically flows over the engine block and over the cylinders and absorbing heat and taking it away from the engine. But another thing is it also prevents freezing, as the name antifreeze might imply. If you look at this graph, it shows different boiling and freezing points for water and coolant, respectively. So if you try to start your car, if it's below 32 degrees and you only had water to cool it, your engine would not have any moving coolant, so it wouldn't be able to cool the engine at all. And actually, this is a bit outdated. Most modern coolants work up to below 34 degrees Fahrenheit, so that when you start your car up, even if it's below freezing, you still will be able to circulate coolant to keep the engine cool, and it won't overheat so that you can still use it without it being a steam or a vapor. This is another diagram of the cooling system. You can see here that coolant exits the radiator, and it's at a cold temperature, and it flows throughout the engine. As it goes, it's absorbing heat and taking it away from the engine so that it can operate at a proper temperature. It comes out the top at a very high temperature, comes into the radiator, And as it cycles through, air from the front of your car will flow over it. The fan works to kind of help pull that air in. But the air then takes heat away from the coolant and then dissipates it. And your coolant is now back to a normal temperature, and then the cycle repeats. And this is how the cooling system keeps your engine at a normal operating temperature.
Great, now we'll cover the oil system. Oil is essential to an engine, and it actually serves many purposes. It'll cool your engine, lubricate the engine, it improves sealing, it cleans, and it prevents corrosion. And so this is why changing your oil on time is so important. Don't let it go. So here is a little animated image again, kind of showing all the things that oil does for your system. The oil galleries are channels that carry oil to various engine parts. We have the oil filter, which removes unwanted material from engine oil, the oil pan, which holds the engine oil, and the oil pump, which keeps oil properly pressurized and flowing throughout the engine. So think about what happens inside an engine if there isn't any oil. What would happen to your engine?
So the next system we're going to talk about is the electrical system. The first part that you might obviously know is the battery. This is what provides power to the different components in this system, but also to the engine itself. Specifically, one of those is the starter motor. When you turn your car on, the pistons aren't moving, so it's not able to rotate itself. So the starter motor is what gets the rotation started so that you can start the combustion cycle and the engine can work as normal. Up top, you can see the distributor. The distributor just channels electricity to the spark plugs at specific timings. These timings are matched up when the pistons inside the cylinder reach their peak when they are compressing the gas and air. At that time, the spark plug will fire and create a spark and cause the combustion cycle to occur and the gas to explode. The alternator is another part that's connected to the rotation of these pistons. As the alternator spins, it's actually generating electricity, and this is used to then recharge the battery and keep it at an operating voltage amperage.
Great, and then we have the exhaust system. So as you can see illustrated here as well, we have all the parts. We have the exhaust manifold that collects gases from multiple cylinders into one pipe, exhaust pipes, and the catalytic converter, which helps reduce the toxic chemicals in engine exhaust, so it kind of cleans that up so it's not emitting all these toxins back into the environment. And the muffler, which reduces the engine exhaust noise, and then the exhaust is eliminated from your car.
So an interesting final point to make, with normal car engines, they're classified as internal combustion engines, which is, as the name implies, combustion cycles happening internally. They're actually not super efficient. As you can see in the diagram, there's only 25% of the energy that comes from the gas that actually is used towards moving the vehicle. A huge part of it is through different powers that's needed to run all the systems. There's different frictional losses just in all the systems and how they connect. A huge amount of energy is lost, as you can see, in the exhaust gas. This can either be the gas that wasn't completely burnt or used, or it could be a lot of heat, which is actually a main cause of the inefficiency of the engine. A lot of energy is gone to just making heat rather than moving the car. This is another reason why a lot of people are really pushing for electric cars versus combustion engines, is just because they're inherently inefficient, especially when electric cars can have anywhere from 75 to 95% efficiencies.
Awesome. So in conclusion, we learned today that engines are made up of multiple systems. And although these systems are separate and have different functions, they all work together. And they're all really important to one another. So we have our fuel system, our air intake system, the oil system, the cooling system, the electrical system, and the exhaust system. And so that's how cars work, car engines work. I really hope you guys learned something from this lesson today. I'll say don't forget to take the quiz, which I can open up here to show you quickly. And there we are. Excellent. Great. Have a good night, guys. Thank you.